Video Tutorial Project by Eric Chang and Robert Bierman. Question 3.
There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, RT, at which people arrive at the ride throughout the day. Time T is measured in hours from the time the ride begins operation. A. How many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer.
B. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer.
C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers.
And finally, D. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers.
As you can see, to the left, we have the graph of RT. Part A, question. How many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer. In order to do this, we need to find the area under the graph from t equals 0 to t equals 3. To do this, we can split the graph into shapes we know, 2 rectangles and 2 triangles. Then we find the area of each of these shapes. 2 times 1,000, 2, 1,000, half times 2 times 200, half times 2 times 200, 5 times 400, 5 times 400, 1 times 800, 1 times 800. When that's done, we get the answer of 3,200.
Part B, question. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. That means, is the rate of people arriving in line greater than the number of people leaving the line? If yes, then the line is increasing. If no, then the line is decreasing. So we have a graph over here. This is a graph of overall rate. And we're not given this graph, but we can create it using the graph that we are given. This graph is the rate of people arriving, and if you shift it down 800 units, you get the rate of people arriving and leaving at the same time. So whenever the rate is above the x-axis, there are people getting into line, and whenever it's below the x-axis, there are more people leaving the line than getting into the line. So between 2 and 3, the graph of the rate is above the x-axis, meaning the area is positive and thus adding to the total number of people in line. Part C, question. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers. Meaning, when is the area under the graph of overall rate the greatest? Well, this is our graph of overall rate that we found in part B. And if we look at it, we can just see that from 0 to 3 is where we have the most positive area. Everywhere else is negative area, which subtracts from the number of people in line. So we need to find the area from 0 to 3, and to do that we can use shapes that we already know. As this enlargement shows, we can split it into 1 rectangle and 2 triangles, whose areas are 400, 2 by 200, and 1 by 200 for each triangle. And that gives us 800. But wait, that's the number of people getting in line. If we add that to the number of people already in line, we should have the total number of people in line. So we need to add the initial condition, which is 700. See, 800 plus 700 is 1,500.
Part D. Write but do not solve an equation involving integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. In order to do this, we need to know the initial value, total amount of people arriving and the total amount of people leaving. We can find these by looking at the question. There are 700 people in line for a popular amusement ride. 700 is our initial. When the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there's a line, people move on the ride at the rate of 800 people per hour. This is the rate of which people are entering. The graph above shows the rate RT at which people arrive at the ride throughout the day. RT is the rate at which people are leaving. With these three values, we could make the equation. 700 people is our initial value. Integral of RT is the total amount of people entering, because the integral of the rate equals total, and minus 800t is the total amount of people leaving, because that's the integral of the rate of people leaving. And we set it equal to 0 because we want to know when there is no longer a line. And that concludes our math project. Hooray!